Hello students, welcome to Sourav Sir's classes. The question is, let Tn is equal to 1 by n into 1 plus 1 by root 2 up to 1 by root n, where n goes from 1 to up to infinity. Then option A, the series summation Tn converges and the sequence Tn converges to 0. Option B, the series summation Tn converges but the sequence Tn does not converge to 0. Option C, the series summation Tn diverges but the sequence Tn converges to 0. And option D, the series summation Tn diverges and the sequence Tn does not converge to 0. Well, so summation Tn is equal to 1 plus half 1 plus root 2 plus 1 by 3 1 plus 1 by root 2 plus 1 by root 3 and so on. Now this series is greater than, this summation is greater than 1 plus half plus 1 by 3. Now since 1 plus half plus 1 by 3, this diverges, so summation Tn diverges. And for the sequence Tn, that is the nth term, is 1 by n 1 plus 1 by root 2 up to 1 by root n. Now multiplying both sides by n, we get ntn is equal to 1 plus 1 by root 2 to 1 by root n, or ntn plus adding 1 by root n plus 1 to both sides, we get 1 plus 1 by root 2 to 1 by root n plus 1 by root n plus 1. Or ntn plus 1 by root n plus 1 by n plus 1, dividing both sides by n plus 1, 1 plus 1 by root 2 up to 1 by root n plus 1. Now this becomes Tn plus 1. So, and the left hand side becomes Tn by 1 plus 1 by n plus 1 by n plus 1 to the power 3 by 2 is equal to Tn plus 1. Thus, from here we get that Tn tends to 0 or Tn tends to infinity. But since Tn is equal to 1 by n into 1 plus 1 by root 2 plus 1 by n, so if we further open it, it is 1 by n plus 1 by root 2n, and it goes on to 1 by 8 n root n. Now when n tends to infinity, all these terms become 0. So this sequence converges to 0. Therefore the correct option is option C, that is the series summation Tn diverges but the sequence Tn converges to 0.